Here we want to talk about area moment of inertia and what it means. So I have this rectangle here, which is a 6 inches by 3 inches. And a rectangle is probably the most common and used shape for engineers, because if you put two rectangles together, one 90 degree to the other, you make a T-shaped cross section. Or if you put three of them together, two flanges and one web, you have an I-beam, and so on. You can make a C-shaped beam, you can make a L-shaped beam, and so on. So here we have this rectangle, and I want to find the moment of inertia of this rectangle with respect to the axis that passes through the centroid. So that axis could be a horizontal axis like this. I'm going to call that X. And then later on we'll do a vertical axis. So these axes going through the centroid of this rectangle. So the centroid is right here, C. So right in the middle. So based on the formula for the moment of inertia of a rectangle with respect to the axis that passes through its centroid, and we call this I sub x, that's equal to 1/12 of its width, in other words the side that is parallel to x-axis, that would be 6, times its height, which is perpendicular to the red axis, so that would be 3 cubed. On the other hand, I with respect to y-axis, it would be just 1/12, and instead of 6 you have 3, and instead of 3 you have 6 cubed. So you can go ahead and calculate I sub x and I sub y. So in this case, I sub x would be 13 and a half, and the unit, by the way, would be inch by inch cube, so that would be inch to the power 4. So actually the dimension of area moment of inertia is length to power 4. And then I sub y similarly would be 54 in this case, inches to the power 4. So what does this mean, these two numbers that we got? What it means basically, the moment of inertia, area moment of inertia, is a measure of resistance of the shape to bending moment. So in other words, if you try to bend, imagine if you had a beam like that, whose cross section was this 6 by 3, and you were trying to bend this about the x-axis, so applying a bending moment like this to it, moment about x-axis, versus if you bend it about y-axis, moment about y-axis. The larger the moment of inertia, it means that it's more difficult to bend it about that axis. So you could see that I with respect to y-axis is like 4 times, larger than I with respect to x-axis. So it's basically, it's 4 times more difficult to bend it about the y-axis than the x-axis.